Hello, Augies Worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today we're going to take a look at something that was sent to me by a company called Olmlmo. Olmlmo. I'm not sure exactly how to pronounce that. It is an electromagnetic field strength meter, all right? And it is available on Amazon for $79. Now, this is the 3-in-1 meter, okay? Now, I recently did a review of a similar one, and we're going to compare the two today. Okay, they claim to be quantitative. Okay, usually a field strength meter is relative. You know, you move the thing around, you find the strongest area and so on. This claims to be quantitative. So let's take a look. If we can, let's take a look at what's in the box. What's in the box is the meter itself, a little USB-C charging cord, USB-A to USB-C. And down in the bottom, you'll find this user manual right here. The user manual is fairly simple. It is in English, okay, all the way through. Basically, what this will do is measure an electrical field. This is at power line. First of all, we turn it on, and I have pre-charged this. Okay, so this has a very annoying beep on it that sets off at pretty low levels. This has 8 volts per meter. Let's put it up near a light bulb, and it goes up pretty fast. Okay, so you can take electrical, and it's in volts per meter. Magnetic, milligauss, okay, and then RF, in milliwatts per meter squared. Now, you'll remember that all the stuff you learned in your Tech General and Extra had to do with RF safety expressed in milliwatts per centimeter squared. Okay, so we're going to have to do a conversion between these two. There's a W electric, a W magnetic. Let's see what those are. A weighted frequency mode. Doesn't say how weighted. Measurement frequency greater than 60 hertz. There's something that it says in here is flat incorrect. Because higher frequencies will produce more radiation damage in the body. For example, at 60 hertz, the body receives 60 electric field pulses per second, while at 120 hertz, the body receives twice as many electric field, or 120 per second. It says, although the electric field remains the same, the damage to the body is twice as great at 60 hertz. That is baloney, because when you're doing it at 120, each pulse is half as long as the other. It's the same strength. So you can get the magnetic and, again, a weighted for the human body. And then a max electrical to electromagnetic. And then the RF frequency range, which is this one right here. Okay, press RF to select the RF mode. The meter will display milliwatts per square meter. Okay, high frequency radiation near cell phones and wireless transmission towers, walkie-talkies. Its measurement band is 20 megahertz to 6 gigahertz. It can measure video signals of current standard 4G and 5G. Okay, the field measurement data of a radio silent area should be less than 0.2 milliwatts per meter squared. You can see right there it's 0.03. That makes this a pretty radio quiet area. And then there's a peak, which is only used for the RF function. Okay, so let's go ahead and measure some things. I have over here outside the screen a 2-meter handheld, and it seems to go very high. If I get it too close, it overloads. You take this in the other room and press the push to talk button. Okay. Now, there, okay, this is from the other room, 4.2 milliwatts per centimeter squared. Okay, that's fine. Now this is the one we want to compare it with, which is the one we've already reviewed. I'm going to turn this on. Okay, and it's in milliwatts per meter squared. Okay, now it's reading higher than this one. Let's take this in the other room again and see what it does. This has got 0.01 to 0.00. This is 0.3 right here. Okay. Now if you'll come back in, stand right about in the doorway there. That's 10 milliwatts per meter squared. This is 0.07 milliwatts per meter squared. Okay? So they don't read the same. Which one is right, I have no idea, to tell you the truth. Now, I do know that when I hold up this radio, it's this Retevis radio that I haven't reviewed yet. If I hold up this radio over here, see, that's well over 10, whereas the other one measures 0.05 milliwatts per meter squared. So, which one do I believe? The answer is, I'm not sure I believe either. This says there is no EMF in the area. I'm talking radio frequency, and I'm mostly using radio frequency because that's what we as hams are interested in. It says 10 megahertz. Let's go ahead and turn on. Okay, what we're doing here is I've got 28 megahertz. That's the 10 meter band CW. I'm down at a CW frequency here, and I'm going out with 100 watts to the hex beam outside, and the house is kind of in the beam pattern of the hex beam right now. Okay, so I'm going to key down. This says 1.2 milliwatts per meter squared. This says 0.05, 0.06. And I've stopped transmitting, so okay, so it averages over a longer period of time, this one. This is 0.7. Okay, so this reading goes up and down, even though I think it should be pretty steady. And it's got this little thing up here on the top. Okay, let's do some calculations. This is in milliwatts per meter squared. Now, if we look at the textbook for a ham radio, we see this right here. This is the exposure limit, 0.2. I mean, the worst exposure limit between 3 and 300. 0.2 milliwatts per square centimeter, whereas this one ostensibly measures milliwatts per meter. So we have to do a conversion. This says 0.2 milliwatts per centimeter squared, 0.2 milliwatts per centimeter squared. Now there are 100 centimeters per 1 meter, okay, and 100 centimeters per 1 meter. Now, you've got to convince yourself that this right here, 100 centimeters in 1 meter, this is unity. Okay, 1 equals 100 centimeters divided by 1 meter. You end up with 1. Okay, so we're going to take 0.2 milliwatts per centimeter squared times 100 divided by 1 centimeters per meter times 100 centimeters by 1 meter. Okay, this is in the denominator here, right? So we've got a centimeter and a centimeter squared. So this centimeter squared cancels with this one and this one. And so we end up with 0.2 milliwatts. And we're going to go times 100 times 100 divided by per meter, and 2 meters squared. Okay, so 0.2 milliwatts times 10 to the 10 to the 4th meter squared, per meter squared. Or this is I got to put this in engineering units, 0.2 milliwatts times 10 to the 3 times 10 per meter squared. Multiply this, that's 20 milliwatts times 10 to the 3 is 20 watts per meter squared. Okay, 20 watts per meter squared. So if we convert this right here to watts per meter, or milliwatts, this is milliwatt. Okay, 20 milliwatts per meter squared. Now, this is claiming that a safe dosage, we got a million here, and we took the milli out with that 3, so it's 20 watts per meter squared. Now that's interesting because this thing can only put out 100 watts. So you go over 5 meters squared, it shouldn't be anywhere near that by the time it gets here. And yet it's showing, so 20 milliwatts times 10 to the 3 divided by meters squared. So this is 1,000, or 20,000 milliwatts per meter squared, 20,000. Okay, so this figure and the figure given in the instruction manual for these are very different. And we note the inverse square law here. As you get away from something, the amount goes down by the square of the distance, or divided by the square of the distance. Okay, till you get down to where it's a so-called safe area. The limits that they have put on these are very, very different from the ham radio limits that we have. Okay, so this is the Olmlmo EMF meter, electric. It's a 3-in-1 plastic, new, made in China. Okay, by this Olmlmo. And that's how you look it up. And as we see on the screen here, it's 79. $80 on Amazon.com in the Olmlmo store. Okay, so you can buy it from them, and you can get it pretty quickly. These things are now available, and you can get multiple colors if you want to choose a different color. So, okay, this little meter is designed to provide an normal electric power field strength, like at 60 hertz or 50 hertz. It'll provide you a magnetic field strength in milligauss, but you won't see that change very much. The electric one you'll see as you get nearer to a source, a light bulb, and so on. And then at RF, it has it in milliwatts per square meter, which is different from the way ham radio aficionados measure things, which is in milliwatts per centimeter squared. And as we discovered in doing some of the math here, the numbers are very different. This thing alarms well before it should for these things here, okay? So you've got to take into account the milliwatts per meter, per square meter, versus the milliwatts per square centimeter, which is what the FCC regulations are given in. So it looks like instead of 0.2 milliwatts per centimeter squared, it's 20 watts per meter squared that is the limit for these. Now, here's the interesting thing. This thing only puts out 10 watts. This particular Retevis only puts out 10 watts. And so how do you get 20 watts per meter with this? And yet this thing shows it. Actually, when we do most of our calculations, we show that if you're more than, say, 3 or 4 feet away from one of these things, you're fine. But if I go 3 feet, see, it sets it off. Actually, it overloads it. And you can tell how much you're looking at there. So these things purport, this is another one here, the Eric Hill, which just does the RF, okay? And this one right here from Olmlmo, the EMMO2, and this is just the Eric Hill multi-fields EMF meter, and it's got measuring range and so on. Okay, these profess to be quantitative. They'll tell you the actual field strength. Okay, they measure differently. So obviously there's either very wide specs or we've got a ways to go on these things right here. Now, we demonstrated a little bit with the radio in the other room about the thing about as the distance goes up, the amount of energy goes down as the square of the distance. So it doesn't take very much distance for the radiation to get below acceptable limits according to the FCC. Do I recommend getting one of these meters, the one that we're looking at right now? Well, it's interesting to have something like this. The first thing I would do is turn off that beep. It triggers at levels that are far too low to do any damage to the human body. But it's an interesting little thing. The Eric Hill, which was sent to me for review, this was sent to me for review. So take reviews with a grain of salt, but I believe those are accurate reviews. I would have one of these, at least, even if it is not, quote, accurate in the sense of an absolute field strength. It is certainly good in the relative sense. So you can measure where you have more RF or less RF in different areas, okay? So that, I think, is the summary of what we've been doing here. So, thank you very much for watching. We have a listing of the patrons at the end of this video. I hope you will join that list. We update this list once a month. And until we next meet, 73.